Hello guys. Okay, this is already the chapter that deals with moment. Depending on the book or most of the book, use this as refers to this as chapter 4. And this is one of the first problems, so it has to be easy, right? Determine the resultant moment about points A, B, and C. C, right here. There are three different questions in the same type of problems, and we can treat them in three different ways. If please go and check the lecture about moment, what is a moment, definition, and everything else. But basically, we are going to talk about moment as is similar to a torque. The difference is that the torque happens about the axis, like this. It's a moment about the axis in this direction, rotating in that way. And then you have two other type of moments which works in one direction and in the other direction, bending moments. These problems refer all the time as bending moment. So moment is equal to force times distance in the scalar formulation, and this is what we are going to do. The only important thing here, not the only, but one very important thing here is the rotation, the direction. So we're gonna assign a direction of rotation for that moment, and we're gonna say that everything that rotates counterclockwise is positive. Although I could say otherwise, I could say everything that rotates clockwise is positive, and I should just put it there in my notation, and that will be it. So basically, important thing, force and distance must be perpendicular, meaning if the force is vertical, the distance has to be horizontal, and if the force is horizontal, the distance is vertical. So let's start with the first question, summation of moments about the point A. I'm going to assume this is positive. Now, we have this force, and this force is vertical, meaning I'm interested in the distance from the point A, which is here, to that distance. Vertical force, horizontal distance. And that would be what? Force, 375, and the horizontal distance is 8. Now we're going to study the sign, the direction of rotation. The way I teach how to do this is you put your finger whatever the point is that you're trying to rotate, and you apply the force in this direction. When you do that, you see the type of rotation that is happening. Basically, what this is producing is this type of rotation, like that. And that rotation will be clockwise. As per our convention, if counterclockwise is positive, that will be a negative value over there. Now, for the next force, let's try to work with this other force. This force has two components, vertical component and horizontal component here. Now the vertical component will be this or this, which is the same, right? It's a box. That would be 4 out of 5 multiplied by F2, 4/5 of 500, which means 400 pounds in that direction, vertical direction. And the horizontal one will be 3 over 5 multiplied by, this one will be 3 over 5 multiplied by 500. Remember, you always go parallel with parallel, parallel with parallel. And this will be equal to 300 pounds. And now you divide and conquer. You start studying the effect of each one of the components. Let's start with this component. Vertical force, the horizontal distance will be this one, 8 plus 6. In other words, will be 400. I'm going to keep it with this. No. 400 vertical force, horizontal distance, 14. And once again, you put your finger at the point that you want to study the moment and apply the force in the direction that it goes, in this direction. The rotation will be in this way, which according to this convention, that rotation will be negative as well. Now what about the force B? The force, the horizontal force here, not the force B, the horizontal component of that force. Well, if you check and you see what happened, that passes through the point A. In other words, you can see this as easy as either the line of action of the force passes through the point, doesn't produce any moment, or you can study this by saying, oh, the force is horizontal, and I need the vertical distance between the point A and the application of that one. And as you can see here, it's 0 because it passes right there. There is no distance. So that doesn't produce any moment with respect to the point A. And the last force will be this force and this component. This component here will be cosine 160 cosine 30, 160 cosine 30. That's 138.56 pounds. And then this one, which is this one, will be 160 sine 30, which is 80 pounds. And we just keep applying the same procedure again and again and again. Let's start with this one. Vertical force, horizontal distance. So it's going to be 138.56 multiplied by the horizontal distance from this point to the point A is 19, right? 8 plus 6, 14 plus 5, 19. And once again, I get that. I apply the force in this direction, and when I apply the force in this direction, it's going to come rotating in this way, which we already established that according to our convention, that was negative. Now this other one here. This other one, the force is the force is horizontal, and it's 80 pounds. So that means that the distance must be vertical between that point of application and the point A. And that value is 0.5 right here. That's the vertical distance between the point and the point, 0.5. Now, when you study design, some people find, including me when I took this course, some people find difficult to see what happens if I pull it in this direction, because that's what you do, right? So what you do basically is that you get, I said you put the finger in whatever way you need to put the finger, right there, and then you apply the force. Well, there is something called principle of transmissibility. And the principle of transmissibility tells you that you can, for effects of calculating the moment, you can move that force anywhere along the line of action of the force. So that means that force over there, instead of putting it there, I can put it anywhere along this line of action. Meaning, if I put my finger there now and I apply the force here, which falls within the line of action, actually what is going to happen is this, and the rotation will be in this direction, and that will be positive. That's easy. It's just vertical force, horizontal distance, horizontal force, vertical distance, study the sign, and that will give you the summation of 4 moments with respect to the point A. So what is this? Let's see. Minus 375 times 8 minus 400 times 14 minus 138.56 times 19 plus 80 times 0.5, and that gives you 1000. I don't think so. I think there is something going on weird here. Let me see. This is negative, this is negative, this is positive. 375 times 8, negative 400 times 14 minus 400 times 14, 400 times 14. That's what I put here, right? I don't know, the value looks a little small for me. 138 times, that's negative, 400 negative, 378 times that, 378, 375 times 8, that's correct. This is 400 times 14, that's correct. This is 138 point, that is correct, plus 80, yeah, that's correct. So the resultant moment is negative 11192.64. Remember, the units are units of force times units of distance, in this case pounds per foot, pounds per foot. Now, what this negative sign means here? The negative sign means that the moment at A of all the forces combined will be, you can keep it in pounds feet, or you can just multiply it in kip or convert it into kip if you want to. I'm going to keep it in pounds, 192.64 pounds per foot. Now, I assume counterclockwise as positive and I got a negative sign. That means that correct direction will be this one, and that means this is clockwise. And that would be the first answer, clockwise. That's easy, right? So let's check the second part. Summation of moments with respect to the point B. I'm going to do the same assumption. This is positive because I feel like it. I don't have to do it, but I feel like it. What is the difference between this problem, this part of the problem, and the other one? Now everything has to be measured with respect to the point B, which is this point here. Every distance. So let's start with this force, 375 force. The force is vertical. And now the horizontal distance is going to be measured from the point B to that point, from here to here, which is 11 times 11. The direction, put your finger at the point B, apply the force. If I apply this force down, it's going to be rotating in this way, like that. And that is positive according to our convention because it's rotating counterclockwise. This is a plus, not the multiplication sign, plus. What about this one? 400 is the value of the force. Distance 5. Once again, put your finger and apply the force. You start doing this later on because basically what I'm doing is I'm applying the force with my finger and I'm using this as a point. When I do that, the thumb is pointing up, means counterclockwise. But if you are not very practical with that, you don't have too much practice, you just put your finger and apply the force down. When you apply the force down, the paper is going to move like that, and that is counterclockwise. That means that is positive as well. Now, for the third force, which is this one, you have to be very careful in this particular case. You know, the point B is here, it's located here on the top. So let's start with the vertical force. The vertical component for that force passes through the point, as you can see. You see? That means that this force is not producing any moment. It's not producing rotation. It will produce translation because it's trying to push it, but it's not trying to make it rotate. So that component basically is not producing any rotation with respect to the point B. Now this other force is horizontal force, value 80. The distance has to be vertical between the point of application and the point where we are calculating the moment, and that's 0.5. Now apply the force, same situation. If you apply the force in this way, you put your finger over there. Whenever you push this in this way, if I push it in this way, this is going to be the rotation. And the rotation is going to be clockwise as well. Positive, positive, positive. Meaning a resultant moment will be just the summation of all of these things here. 375 times 11 plus 400 times 5 plus 80 times 0.5, and then you get 6,165 pounds per foot. And I assume counterclockwise as positive, and I get a positive result. That means that will be counterclockwise, the rotation. And that will be the second answer. Now the third part is asking with respect to the point A. I'm sorry, point C, which is this one. I'm going to assume this is positive as well. And the procedure is the same. Put vertical force, 375. Horizontal distance between this point and that application, 8. Rotation, put your finger, apply the force in this way. When you apply the force, this is going to rotate clockwise, meaning it's negative according to our convention. Second one, this one, 400. Vertical force, distance, horizontal, 14. Put your finger at the point, apply the force in this way. When you apply the force and you push down in this point, the rotation is going to be like this, meaning clockwise is negative. Now let's go to this third force. Now, if you are dealing with the point C, the vertical component is this one, right? It's going to be 138.56. The distance must be horizontal, meaning from here to there, 8, 14, 19. Put your finger, pull it in that direction. You pull it down in this way, pull it down in this way. It's going to rotate negative also according to our convention. And now the last force is this one. As you can see, this component passes through the point C. And because this component passes through the point C, it doesn't produce any moment. So that will be it. Let's see how much is this. 375 times 8 plus 400 times 14 plus 138.56 times 19. And you heard me saying plus, 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 right? Yeah, because all of them are negative. Now I'm going to add the negative sign here. 11,232.64 pounds per foot, meaning the moment with respect to the point C, summation of moments with respect to the point C, will be 11,232.64 pounds per foot. And because I assume counterclockwise was positive and I get a negative value, that means that it will be clockwise direction. And that will be it. You see, basically you have 3 problems into one here, but all of them are the same. How do you do that? Divide and conquer. Find every component in the horizontal and vertical directions. Then apply the multiplication, force times distance. If the force is vertical, find the horizontal distance. If the force is horizontal, find the vertical distance. And study the rotation of each one of those forces individually with respect to the point that you want to calculate the moment. Add them up, and that will be the solution. Thank you for watching, guys. See you in the next video.